over to some of the examples over here. Now suppose we take a pure substance. So pure substance will always constitute a single phase. Here I have written some of the examples for your daily reference, and they all are, I suppose, very simple. Let me pick them one by one. So if we are having a pure substance, then it's very simple. It will be a one phase system and a one component system. And if we calculate the degree of freedom, that will come out to be F is equal to C minus P plus 2, and 1 and 1, that will come out to be 2. Okay. Now suppose we have a mixture of gases. So gases, they always mix freely with each other, and so they always constitute one homogeneous phase because they mix with each other freely. Suppose we are taking N2 and O2, then the number of components will be 2, but the number of phases will be 1. Why? Because gases mix with each other freely. Okay. Now let's come over to an aqueous solution. Suppose we take an aqueous solution of KCl. Aqueous solution is when you mix some salt in water. Okay, aqua comes from water. So when suppose you mix KCl in water, then what will happen? You will get an aqueous solution of KCl, and in this case we will be having two components. One is the KCl and another will be the water. But it will constitute only one phase. Okay, because we are having an aqueous solution. But if we are taking a saturated solution, suppose आप पानी लीजिए, पानी में आपने नमक को घुलाया, तो अब क्या हुआ, हमारे पास aqueous solution of NaCl आ गया. Okay, now this is two component system, but there is one phase. Okay, अब इसमें अगर आपने सैचुरेटेड सॉल्यूशन बनाना होता है तो क्या करते हैं, और ज़्यादा उसमें घुलाते हैं, नमक और ज़्यादा घुलाते जाते हैं, नमक खूब सारा नमक घुला जाते हैं. उसके बाद क्या होता है, सैचुरेटेड सॉल्यूशन की क्या पहचान होती है कि आपने जिस वेसल में उसको घुलाया है उसमें नीचे थोड़ा सा सॉल्ट का डिपोजिशन आ जाएगा. दिस इज सॉलिड NaCl. ओके, एंड दिस इज आवर aqueous solution of NaCl, and this is, since it is a saturated solution, उसमें थोड़ा सा सॉलिड नीचे सेटल हो जाएगा, तभी तो सैचुरेटेड सॉल्यूशन होगा ना. तो दिस इज इन सॉलिड स्टेट. नाउ हाउ मेनी फेजेस विल बी देयर? one is this phase, one phase is this, and the other phase is this solid NaCl. Okay, so this is actually two phase system. Two phase, and obviously the number of components will be 2 in this system. Now let's come over to solids. So suppose we are having one pure solid, obviously it will be one phase. But if we are having two solids, suppose we are having calcium fluoride and we are having calcium oxalate. Okay, so it will constitute two phases. So as many solids are there, as many phases are there. But if we are having a big chunk of calcium fluoride and suppose we break it to two pieces, then again we will be having only one phase. Okay, it will not be two phase. Suppose we break it into 5 pieces, then again we will be having only one phase. But as many solids are there, different solids are there, different phases will exist in the system. One example is of calcium carbonate decomposition, where we have calcium carbonate and calcium oxide as well as carbon dioxide gas also. So in this system what will happen, we will be having two solid phases and one gaseous phase. Okay, but the number of components is 2. I have already explained this in my introductory video, that the decomposition of calcium carbonate, it has two solid phases, one gaseous phase, but the number of components are 2. Okay, now let's come over to allotropes. So allotropes, there are as many phases as the number of allotropes are there. Suppose you are having carbon, then carbon is graphite, carbon is diamond, and carbon black. So there are many allotropes, and as many allotropes, as many phases will be there. Now let's come over to a typical example I have taken over here from your books. Two ice cubes floating in water in a closed container in presence of water. So what will happen? We are having two ice cubes, but it will be a single phase of ice, solid ice. Okay, so one phase will be this, two ice cubes. This will constitute one phase floating in water. Since water is there, it is in the liquid state, so it will be another phase. Now comes in presence of water vapor. So this will be our third phase. So how many phases will be there? There will be 3 phases. 2 ice cubes in water in presence of water vapor. So it will constitute, there will be one solid phase of 2 pieces of ice, one liquid phase of water, and the third gaseous phase which will be of the water vapor. So in fact there will be 3 phases, but the number of components here will be only one. Single chemical entity is required here to express all the phases in this system, and that is H2. So the number of phases here are 3, but the number of components is 1. If we calculate F from the formula of Gibbs phase rule equation, then F is equal to C minus B plus 2. That will come out how much? It will come out to be 0. So if these are in equilibrium, then only you will have to apply this degree of freedom. Okay? When the system is in equilibrium, then the degree of freedom will be 0. In such a case, when we are having ice cubes in water and water vapor, these all the things are in equilibrium, as we find in the water system at triple point. Okay? And that triple point has a certain coordinates, fixed coordinates of temperature of 0.0075 degrees centigrade and a pressure of 4 point something mm of H. Now comes this example, which you have encountered this example when you are studying the sulfur system. The rhombic sulfur is in equilibrium with the monoclinic sulfur. So this will have constitute 2 phase, because they are the allotropes of sulfur, and obviously component will be 1. Why 1? Because both these phases, they are represented by a single chemical entity, and that is sulfur. Now let's take this example. Iodine as I2 is in equilibrium with its vapors. So when iodine is in equilibrium with its vapors, it will constitute 2 phases. One is the solid phase and another is the gaseous phase. So it will again be a one component system, since both the phases in this system can be represented by a single chemical entity, and that is iodine. And the number of phases will be 2. One is the solid phase and another one is the gaseous phase. So component will be 1 and the number of phases will be 2, and if we apply the degree of freedom, if we calculate the degree of freedom from the Gibbs phase rule equation when the system is in equilibrium, then F will be equal to C, that is 1, minus P, that is 2, plus, and that comes out to be 1. Okay? So degree of freedom will be 1. And these are some very simple examples, and you can have MCQs based on these examples, like all these examples I have listed, though they are not a complete list of all the examples, but I will here tell you 2 or 3 more examples which will help you in understanding the concept better. So come on, I will tell you about the dissociation of PCl5 and about the decomposition of NH4Cl also. You will be able to understand in that way very easily. Now let's come over to a very interesting example of decomposition of phosphorus pentachloride, PCl5 का decomposition देखते हैं. तो कैसे decompose होता है? PCl5 it decomposes to PCl3, phosphorus trichloride, and chlorine gas is evolved. So here we can see that there is a solid phase of PCl5, there is a liquid phase of PCl3, and a gaseous phase of Cl. So here we are having 3 phases. At equilibrium we are having 3 phases. One is the solid phase, another is the liquid phase, and one is the gaseous phase. So the number of phases are 3. So now let's calculate the number of components over here. So we can see that if we give a view of this equation, we find that there should be 3 components in fact. One is PCl5, another is PCl3, and another is Cl2 if we view this equation. But all the phases in this system can be represented by two components. And let me tell you how. So let's take only two chemical entities, PCl5 and Cl. Out of these three chemical entities, let us take only two chemical entities, first PCl5 and Cl. Now let's take the first solid phase, which is PCl5. And we see that we can represent this phase with the help of these two chemical entities like this. PCl5 plus 0 Cl. Now let's take this phase PCl3. And we can represent this phase also with the help of these two chemical entities only. How? PCl5 minus Cl. We know that algebraic signs are allowed in these representations. Now let's take the third phase, which is our gaseous phase Cl2. Cl2 can be expressed as Cl2 can also be expressed by these as PCl5 and plus Cl. We will place 0 coefficient over PCl5. In this way, we can see that we can represent all these phases with the help of only two chemical entities, that is PCl5 and Cl. Now let me further clarify this to you, that instead of taking PCl5 and Cl, you can take any chemical entity of your own choice. So let's take over here PCl3 and Cl. PCl3 and Cl. And let's see, can we represent all the phases taking these two chemical entities? So let's take our first phase PCl5. So we can represent PCl5 by PCl3 plus Cl. So we can represent this phase. Now let's take this phase PCl3. For PCl3, how we can represent it? By Cl2 and PCl3. We will place a 0 coefficient over here, and in this way PCl3 can be easily represented. Now let's take our third phase Cl2 and the two components PCl3 and Cl. PCl3 plus Cl. Here we will place this coefficient 0 before PCl. And so we can see that with the help of these two chemical entities, we have been able to express all the phases of this system. Similarly, we can take the other leftover two chemical entity. I think it is PCl5 and PCl3, and we can express all the phases in the similar manner, employing the algebraic plus or minus sign and putting the coefficient of 0 wherever required. So in this manner, we see that we can express all the phases in this system with the help of only two chemical entities. Thus, it is a two-component system. So the decomposition of phosphorus pentachloride PCl5 into PCl3 and the chlorine gas, it is a three-phase system but a two-component system. Okay, and likewise you can calculate the degree of freedom also from the Gibbs phase-equal equation F is equal to C minus P plus T. So this was an example of the decomposition of phosphorus pentachloride, and likewise you can also calculate for the decomposition of calcium carbonate as it decomposes into calcium oxide and carbon dioxide gas. In that case, we will be having two solid phases. One is the calcium carbonate, which is in solid state. Calcium oxide, it will be again in a solid state, and carbon dioxide gas, which will be in the gaseous state. So there will be two solid phases and one gaseous phase in case of decomposition of calcium carbonate. And in a similar manner, you can find out that there also the number of components will only be 2. So that also will be a 3-phase system with 2 components, 3-phase and 2 component system, like the phosphorus pentachloride decomposition just now as you have seen. It is also a 3-phase and a 2 component. Now I will tell you a very interesting example of decomposition of ammonium chloride, and here we will see that it can have 1 component as well as it can be a 2 component system also, depending on the quantities of the NH3 and the HCl which are produced by the decomposition of ammonium chloride. So let me rub it and I will show you the decomposition of ammonium chloride and the number of phases and the number of components. So now let's come on to a very interesting example of decomposition of ammonium chloride. तो जैसे हम लोग इस इक्वेशन से देख सकते हैं, इक्विलिब्रियम इक्वेशन से अमोनियम क्लोराइड डिकम्पोज होकर के NH3 गैस बना रहा है और HCl गैस बना रहा है। तो ये क्या है, ये है सॉलिड स्टेट में और गैसेस, 2 गैसेस से बन रही है एंड सिंस गैसेस मिक्स फ्रीली विद ईच अदर, तो ये एक फेज हो गई और ये एक फेज हो गई। तो इसमें 2 फेजेस होगी, एक सॉलिड स्टेट में होगी NH4Cl and another again NH3 and HCl again, that is if it is in equilibrium, that again it will be NH4 in the gaseous, the vapor state. So we will be having 2 phases over here, one is the solid and another is the gaseous state. लेकिन जब हम कंपोनेंट को कैलकुलेट करने चलते हैं तो बहुत ही इंटरेस्टिंग फीचर जिसमें नजर आता है वो ये है कि अगर NH3 और HCl दोनों प्रोड्यूस हुए हैं फ्रॉम डिकम्पोजिशन ऑफ अमोनियम क्लोराइड, ये अगर इक्विवेलेंट अमाउंट प्रोपोर्शंस में है तो इसका नंबर ऑफ कंपोनेंट 1 होगा, लेकिन अगर ये इक्विवेलेंट अमाउंट में प्रोड्यूस नहीं होते हैं तो इनका नंबर ऑफ कंपोनेंट्स 2 होगा। लेकिन कैसे, आगे देखते हैं। जब ये इक्विवेलेंट अमाउंट में होंगे तो मान लीजिए फेजेस हैं हमारे, ये नंबर ऑफ कंपोनेंट्स। गैसियस फेज में क्या है, NH3 and HCl, again when it is in equivalent amount that will amount to NH4Cl. So we can express both the phases, the gaseous phase as well as the solid phase by a single chemical entity, and that is NH4Cl. Okay, so it is a 1 component system when NH3 and HCl are present in equivalent amounts, then it is a 1 component system. Now another case comes when HCl and NH3 are not present in equivalent proportion. Okay, so let's suppose this is NH4Cl decomposing to give and it is give X times of NH3 and Y times of N, means one of the and that X be greater than Y, means one of this constituent is present in excess. Let it be NH3. Okay, since I have taken X is greater than Y, this means NH3 is present in a bit excess than HCl, means they are not in equivalent proportion. So how we will represent the gas phase now? Gas phase will be X NH3 plus Y HCl. This is our gaseous phase. Okay, they both are in gaseous state. So this is our gaseous phase. So X times of NH3 plus Y times of HCl, and since X is greater than Y, so how we will write it? Y times of NH3, we have taken Y times of NH3 from X. Okay, from X times of NH3. So Y times of NH3 plus Y times of HCl plus the remaining X minus Y times of NH3 will be here. Okay, suppose this is 10 and this is 5, then if we take 5, then the remaining will be 5. The same you can apply over here. So Y times of NH3, how much will be left? X minus Y. Since X is greater than Y, so X minus Y will be left over here, that we are considering over here. So Y times of NH3 plus Y times of HCl plus X minus Y times of NH3. Now this Y times of NH3 plus Y times of HCl, this will constitute Y times of NH4Cl plus what is remaining over here? X minus Y NH. Okay, so we are taking the 2 constituents, 2 chemical entities over here, and that is what? NH4Cl and NH3. With the help of NH4Cl and NH3, we will be able to explain both the gaseous as well as the solid state. So to express the solid state, we are having NH4Cl, and that can be expressed as NH4Cl plus 0 times of NH3. So we can say that by taking these two chemical entities NH4Cl and NH3, we are able to explain both the phases of this system. The gaseous phase is represented as y times of NH4Cl plus x minus y times of NH3, and our gaseous phase can be expressed as NH4Cl plus 0 times of NH. So here we have taken two chemical entities NH4Cl and NH3, and we have been able to explain all the phases of this system, decomposition of ammonium chloride. Okay. We can do this by taking HCl in excess also. Suppose it was Y greater than X, then also we can have proceeded in the similar manner. But now taking the chemical entities as NH4Cl and HCl. In a similar manner, we could have found that we would have been able to express the gas phase by two chemical constituents. That would have been, in that case, when HCl is present in excess, then it would have been NH4Cl and X minus Y times of HCl, and the solid phase we could have expressed as NH4Cl plus 0 times of HCl. In this manner, we find that we can express both the phases by taking two chemical entities. So it will be a two component system whenever one of the chemical constituent HCl or NH3 is present in excess. Okay. So what we find here is in the decomposition of NH4Cl is that when NH3 and HCl they are present in equivalent proportions, then always it is a one component system. But if either NH3 or HCl is present in excess, then always it will be a two component system. Okay. So these are some of the simple problems which I thought I must share with you. One more example I would like to recite over here. That is, suppose we are having N2, nitrogen, hydrogen and ammonia in a vessel, separate, independent of each other, and there is no reaction, no equilibrium has been set up between them. Then what we will have three components. It will be a three component system. Okay. But since these gases mix freely with each other, so it will be it will constitute one phase system. Like I am taking this example because it is a famous Haber process of production of ammonia, and moreover it is a very common question also. So if they are present independently in a vessel, then it will constitute three phases. But if their equilibrium has been set up between them, there is a reaction between them at appropriate pressure and temperature. They are reacting with each other and forming ammonia. Nitrogen and hydrogen are reacting and forming ammonia. Then again that will constitute the number of phases will be one, but that will constitute different components will be there, two components I think, and depending on the equilibrium constant. So equilibrium constant has been set up, then it will be a one component system because we know the concentration of one of them and we can calculate the concentration of this. Okay, so these were very simple problems. If you encounter any of the problem which you are not able to get a solution to it, then you can write it in the comment box, and I will try my level best to solve it. Okay, thank you very much.